This conversation is powered by Google Illuminate. Check out luminate.google.com for more. Ever wondered, how sunglasses actually work? It's more than just, blocking the sun.
It's all about polarized light. And this paper dives into that, but on a much bigger scale.
Bigger scale, like alien sunglasses?
Not quite aliens, but we're talking about electromagnetic waves and how we can control their polarization.
So, like manipulating light itself sounds intense. So let's start with the basics. What exactly is polarization?
Imagine light waves vibrating in all directions. Polarization is like filtering those waves so they only vibrate in a specific direction. Think of it like shaking a rope up and down versus side to side.
Right. So sunglasses are basically light filters?
Exactly. They only let through light vibrating in one direction, reducing glare.
This paper talks about a circular electromagnetic wave passing through 3 polarizers. What's the deal with that?
Each polarizer changes the direction of the wave's vibration. The first one creates linearly polarized light. The second one further refines it. The third one, it depends on the angles.
So it's like a game of light bending.
Exactly. You can control how much light gets through by adjusting the angles of the polarizers.
The paper mentions a visualization. What does that look like?
It shows the electric and magnetic fields of the wave as it passes through each polarizer. Red for electric, blue for magnetic. It's really cool to see how the wave changes.
I see. And you can control the angles of the polarizers?
Yep, you can adjust them and see how it affects the wave's polarization in real time. There are also controls for other variables like electric field magnitude and wave velocity.
So why is this important? What are the applications of this kind of control over electromagnetic waves?
It's fundamental to many technologies. Think about LCD screens, 3D glasses, even some types of radar systems. Understanding and controlling polarization is key.
So it's not just about sunglasses anymore.
Not at all. It's a core concept in optics and electromagnetism with wide-ranging applications.
The paper lists Fremont Tang, Fu Kun Wang, and Lukang as authors, and it mentions a license. What's the story there?
It's open source. The authors have made their work freely available, encouraging others to build upon it. That's a big deal in the scientific community.
Right, so anyone can use and adapt this research?
Exactly. That's the beauty of open source science.
The second document seems to be a website with a lot of educational resources. How does that relate to the first paper?
It's a platform showcasing interactive simulations, including the circular electromagnetic wave polarizer. It's a great way to make complex concepts more accessible.
So it's like a digital textbook with interactive elements.
Exactly. It makes learning about polarization much more engaging.
These simulations, are they easy to use?
They're designed to be user-friendly, even for those without a strong physics background. The interactive elements make learning fun and intuitive.
That's good to know. So it's a great way to visualize abstract concepts?
Absolutely. Seeing the wave change in real time helps solidify understanding.
Is there anything else we should know about this research or the website?
The website has a wealth of other simulations covering various physics and math topics. It's a fantastic resource for students and educators alike.
So it's a one-stop shop for interactive learning?
Pretty much. It's a great example of how technology can enhance education.
The emphasis on open educational resources is really interesting. Why is that so important?
Open access ensures that educational materials are available to everyone, regardless of their financial situation. It promotes inclusivity and expands access to knowledge.
Makes sense. So it's about democratizing education?
Precisely, making quality education accessible to all.
So to wrap things up, this research on the circular electromagnetic wave polarizer is not only fascinating, but also incredibly practical and impactful.
It highlights the power of open source science and the potential of interactive simulations to revolutionize education.
And it all started with a simple question about how sunglasses work. It's amazing how something as hopingly simple as polarized light can have such far-reaching implications.
It really shows the interconnectedness of science and technology and the importance of making knowledge accessible to everyone.
Absolutely. Thanks for shedding light on this topic. That was a great discussion.